In this video, I will show you how to get the equations of the tangent and normal line when you're given a problem that says so. So we're gonna start here. Here I have a graph. I have a parabola, and we know that when we take the derivative of something, we get the slope of the tangent line. The tangent line, let's imagine the point here. The tangent line is the one, this black line, that goes through the point and touches the parabola just once. And then we have the normal line. The normal line is perpendicular to the tangent line. It's this one green over here. And just to refresh your memory, we know that the slope of the secant line is going to be f of x plus h minus f of x over h. And to get the slope of the tangent line, we're gonna take the limit when h tends to 0 of the slope of the secant line, and to get the slope of the normal line, we have an example here. Slope of the tangent line equals 4. The slope of the normal line will be -1 over 4. We're gonna take the reciprocal of the slope of the tangent line to take the normal line. In algebraic expression, if we have the slope of the tangent line being a, then the slope of the normal line will be -1 over a. So we have here this first example, x squared plus 1. We're gonna evaluate the slope of the secant line, the slope of the tangent line, slope of the secant line, and the equation of tangent and normal line. So let's start by taking the slope of the secant line. Slope secant. Now I'm going to replace this x plus h wherever I see an x. For example here. So we're gonna have x plus h squared plus 1. And since we have over here minus f of x, which is the function, minus the function x squared plus 1. So we have the function evaluated when x plus h minus the function original of this over h. So we have here a binomial expansion. So we have x squared plus 2xh plus h squared. You should remember this when we have a plus b squared. This is equal to a squared plus 2ab plus b squared. This is the same thing I did over here. So continuing, this negative is going to distribute the x squared plus 1. So we're going to have minus x squared minus 1 of this over h. Now we're going to combine like terms. We have x squared minus x squared. So we're going to have, and we have a plus 1 over here. Sorry, plus 1. So we have plus 1 and then minus 1. So we end up with slope secant 2xh plus h squared over h. Now here we have a common factor, so we should take out the h. If we take out the h, we end up with 2x plus h over h. This cancels with this h. So slope of the secant line is going to be 2x plus h. Now, we want the slope of the tangent line. The way we do this, we're going to take the limit when h tends to 0 of 2x plus h. Now we're going to replace wherever we see an h with 0. So we're going to have 2x. This is the slope of the tangent line. Slope of tangent line. Slope of the tangent line. So now we have the formula for the slope of the tangent line. We're asked the equation of the tangent line though. So now we're going to need a point to get the equation of a line. So the way we do this, we know we have this function x squared plus 1, and the problem says that we're going to evaluate the function when x equals 2. So when x equals 2, when x equals 1, sorry, when x equals 1. So we're going to evaluate this function when x equals 1. So we have f of 1, 1 squared plus 1 is 2. So we have a point now. We have the point 1 comma 2. So now we need to find the slope of this line. In order to do that, we need to get our slope of the tangent line, and now we're going to replace 1 because we're working with the point 1. So 2 times 1, 2. The slope is 2. So now we have very important information here. We know that x equals 1, y equals 2, and that the slope tangent equals 2 as well. So to get the equation of the line, we're going to use point slope formula, y minus y1 equals m times x minus x1. And now we just replace y1, x1 with our xy values, and the slope with our slope value. So we end up with y minus 2 equals 2 times x minus 1. We apply the distributive property, y minus 2 equals 2x minus 2, and we send the 2 to the other side by adding it. We have that y equals 2x minus 2 plus 2. Y equals 2x. This is the equation of the tangent line when x equals 1. Now to get the equation of the normal line, we're going to take we know that our equation of the tangent line is 2x. We're going to take the reciprocal. We know that our slope tangent is 2. Then our slope normal is going to be minus 1 over 2 because we took the reciprocal. So using this and using our point 1 comma 2 as we used before, we're going to use the point slope formula again. So now we have y minus 2 minus 1 half x minus 1. So we have y minus 2 minus 1 half x. So we have negative times negative is positive plus 1 half. Y equals negative 1 half x plus 1 half plus 2. So now we have this, we have to add this. So the way we do this is we have an invisible 1 here times 2 times 2. At 1 half x plus 1 half plus 4 over 2. So our final equation of the normal line is going to be negative 1 half x plus 5 over 2. Now I'm going to show this on Desmos. So we have that our equation is x squared plus 1. We have our parabola over here. We have that our normal line, our tangent line is 2x. You can see over there at point 1 comma 2 as we said. And our normal line is going to be 1 half x plus 5 over 2. Minus 1 half x. Minus. So we have there at 1 comma 2, we have a perfectly perpendicular line to the tangent line, which is the normal line. So we have here this next example. F of x equals 4 minus 2x minus x squared. Now we know that we have to find the slope of the secant line. We know that is 4 minus 2 x plus h. I'm just applying the definition of the derivative using limits, x plus h squared. And then we're going to have 4 minus 2x minus x squared. All of this over h. Now we have 4 minus 2x minus 2h minus, this is a binomial elevated to the square. You should know the expansion, but I'll write it anyways. Here we have x squared plus 2xh plus h squared. This is the expansion. But since we have a negative sign, this negative is just going to turn this all into negatives. So we're going to write it negative. And then this negative is going to distribute all of these three terms. So we have minus 4 plus 2x plus x squared. Negative times negative is positive. And all of this over h. And now we have to combine like terms. We have minus 2x plus 2x. We have 4 minus 4. And we have minus x squared plus x squared. So they all cancel out and we're remaining with this here, here, and here. So we have minus 2h minus 2xh minus h squared over h. And we can rewrite this because here we have a common factor, so we take it out. H minus 2 minus 2x minus h. We eliminate this. So here we have slope of the secant line minus 2 minus 2x minus h. So now we're going to apply the limit x tends to 0 of minus 2 minus 2x minus h. And now we substitute 0 when we see an h, and this is going to be minus 2 minus 2x. And now we need to know, the question is asking us to find the slope of the tangent and the equation of the tangent line when x equals 0. When x equals 0. So since we have the slope of the tangent line here, we might as well evaluate right away. So we have minus 2 times 0. So here we have that the slope of the tangent line is going to be negative 2. Negative 2. Now we have the slope. We just need one more thing to get the equation, which is a point. So we get the point by evaluating the function at the point that we're being asked. So we're going to evaluate this function when x equals 0. We're going to have f of x 4 minus 2 times 0 minus 0 squared. We have f of x equals 4. So we have that our point is 0, 4, and our slope is negative 2. So now we're going to use point slope again, y minus y1, m x minus x1. Now we have y minus 4 equals negative 2 times x minus 0. So y minus 4 equals negative 2x. And negative 2 times 0 is negative 0. So we have that the equation of the tangent line is going to be minus 2x plus 4. Now we're going to get the equation of the normal line, and we're going to apply the reciprocal to the slope of the tangent line. slope of the normal line is going to be negative 1 over negative 2, which is going to be positive. So we have that the slope of the normal line is 1/2. And now we're going to do point slope formula again. Y minus 4. Now we have a 1/2 x minus 0. We have y minus 4 1/2 x, y equals 1/2 x plus 4. So there you have it. You have slope tangent and slope normal. And now we're gonna see this in the calculator. We have this equation of the tangent line. We have minus 2x plus 4. There you have it at point 0,4, and then we have 1 over 2x plus 4 right there, perpendicular to the tangent line.